Okay, now hello everyone. Today my presentation is about the computer version. And first, it may become a question about what is the meaning of the computer version. So I think we can make an analogy. First, this is our brain, and this is a computer. We can see that computer is an extension of our brain because they help us perform complex calculations. For example, if we had a function that is not easy for us to calculate by hand or by our brain, we can use the computer. So the situation is the same for the computer version. It's an extension for our eyes. We can use computer version to capture the version around us, the buildings, the vehicles around our lives. So there is a definition about the computer version. It was from a textbook, Computer Version Algorithm and Applications, written by Richard. He said computer version is a way to understand interpret the visual interpret the visual world through images, enabling machines to analyze and process visual information in ways that mimic human perception. So this definition may become a little bit complex, I will break the computer version into four main parts and introduce them one by one. The first is image acquisition. Second one is image calibration and stereo matching. And the last one is 3D reconstruction. And I will introduce them one by one. The first is image acquisition. For a computer version, it uses wireless cameras to take pictures and extract the information in the picture into a string of RGB values. And into a string of RGB values, the computer can recognize and process these RGB values through a per set algorithm. But however, in the process of image acquisition, there will be a various interference factors such as the hue difference or the distortion, etc. Image calibration is image calibration is to process the image according to these interference factors. We need to modify the raw picture and make it much more clear. This is image calibration. And in the same sense, cameras at different angles will take different pictures. For example, this one is maybe the front page, a front angle, and maybe this one is the side photo. So the corresponding relationship between these pictures in real life is established and displayed in the form of pictures. We combine the obtained we combine the different photos together and then make and then established the corresponding relationship between this picture in real life. The last part is a 3D reconstruction. Sometimes we need to combine the obtained stereogram with the camera parameters, like the resolution or the frame rate. We combine them together to restore the 3D coordinates in the sense, and 3D reconstruction is complicated. We combine them together and make the 3D reconstruction. And this is a brief introduction to the computer version. And you may be asked, is there some example of this application, of this method, of this technique? The first come to my mind is Tesla's FSD system. It's a full self-drive system. The third picture is a screenshot of a video in Bilibili, a video website in China, a popular video website in China. And you can see in Tesla 3D modeling, a person's location is currently identified. Because you can see the third picture, there is a uh, there is a person stand behind a vehicle, and in the 3D modeling, you can see that it is accurately identified. So it is precisely because of Tesla's accurate modeling that autonomous driving is possible. And this is my presentation. Is there any questions? Is there any questions about the presentation? 潘作业, do you have some questions?
Okay, I have some question about you about are there any examples of computer vision that we are related to today? And because autonomous driving is now something that everyone has experienced.
Okay, of course. For example, the QR code payment, which is very popular in China, is when the version recognize is an application of computer version, because the computer recognize the pattern of the QR code and they process it so that you can pay through the QR code. And I think this is an example.
Okay, I know. Very thanks.
Okay, thank you.